Alright, so this is Algebra 1. We are working on our practice final. Let's zoom out to the correct width. The first question that we had was number 9. So number 9, this one, I'm trying to get all the k's on one side, so I'm going to subtract k on both sides. I guess I can zoom in here a little bit more. If I subtract k and subtract k, those k's both cancel out, and I'm left with -7 is equal to -9. Whenever I have two numbers that are not equal to one another, the answer is no solutions. And just for your notes to make sure you have it, if I had something like 1 was equal to 1, that is infinite solutions. And of course I could have gotten something like, I don't know, x is equal to 7, and that was the one solution, right? So that was number 9. You guys can always raise your hand to throw on the brakes or ask a question. Otherwise, I'm going to be moving on to number 11. All right. So number 11 is solving this inequality. Right now, I need to isolate the variable, isolate n. N is being divided by 18, so the inverse operation of divide by 18 is multiply by 18. I'm going to multiply the left-hand side by 18, multiply the right-hand side by 18. Technically, that's 18 over 1, if you want to make it a fraction times a fraction. Whenever I'm multiplying fractions, I can cross-cancel. If I have an 18 on the top and the bottom, the numerator and denominator, I can cross both of them off. If I cross both of them off, the only thing that I have on the left-hand side is the n. I'm going to copy down this sign. The sign will only change if I multiply or divide by a negative. If I add or subtract by a negative, nothing happens. It stays the same. I have multiplied by a positive, so it does not change. And 2 times 18 is 36. My final answer is n is less than 36. So that was number 11. Question, yes, Larissa.
Can you also do number 12?
Yeah, number 12. So number 12 is very similar to number 11. It just has an additional step. I could multiply every single number by 2 right now, but I think what's a little bit easier is to first subtract 8. Again, when I'm solving for an equation, or in this case an inequality, I'm kind of doing reverse PEMDAS. I'm going AS, then MD, E, then P. So the first thing that I see is the addition that I can undo in terms of reversing PEMDAS, so I'm going to subtract 8 on both sides. When I subtract 8 on the left-hand side of the inequality, I'm left with x over 2, because those 8's cancel out. And 4 minus 8 is -4. And I'm going to copy down this inequality because I have not multiplied or divided by a negative. I only subtracted. There's no multiplication or division happening. Now the question is, how do I undo dividing by 2? What is the inverse operation of dividing by 2? And that's multiplying by 2. So multiply both sides by 2. And now that I'm multiplying, I'm kind of scared. Okay, I'm multiplying, so if I am multiplying by a negative, that's the thing that's going to cause me to flip the sign. But I'm multiplying by a positive, so nothing happens still. The 2's cancel out. I'm left with x on the left-hand side of the inequality. So I say x is less than, and then 2 times -4 is -8, and that is my final answer. I'm multiplying by a positive. I'm multiplying by a positive 2 in this case.
It only changed if
You multiply or divide by a negative, yeah. I saw Jade's hand first, and then we'll do Esha next.
Can you do it the opposite way?
Another different way?
No, multiply it by 2 first.
Yeah, so let's see what happens. So x over 2 plus 8 is less than 4. So this one, I'm going to first multiply every single term by 2. Technically, the left-hand side of the inequality and the right-hand side of the inequality are being multiplied by 2. I'm distributing that 2. These 2's cancel out. I'm left with x. 8 times 2 is 16, and 4 times 2 is 8. And then from here, I'm going to subtract 16 on both sides. Minus 16, minus 16. Those cancel out, and I'm left with the final answer. X is less than -8. So a different path to get there, but equally valid. Yeah, good question. What about you, Asha?
Well, I was just wondering how you got to -8 because I got -12, but I found my mistake and did that.
Ah, perfect. Yeah, good catch. Yeah, I love it when students catch their own mistakes because that is the best way to learn. Other questions on 11 or 12? Otherwise, we are moving on to number, looks like 23. No, number 20. 20 and then 23. Yes.
Did you number 7? I just went over and I got that one.
Yes, let's come back here to number 7. This one, I'm going to first you would think, okay, I can undo the subtraction. Unfortunately, it's kind of trapped in this division. So first you have to undo the 4. You have to multiply both sides by 4 first. So multiplying both sides by 4, and I get those 4s canceling out. I'm now left with b plus 2 on the right-hand side of the equal sign and 8 on the left-hand side. And then from there I subtract 2. So minus 2, minus 2. Those 2's cancel out, and b is equal to positive 6 for number 7. All right. Yeah, I really appreciate people finding their own mistakes. Asha, did you have a question? Or sorry, not Asha. Emma, did you have a question?
Yes, number 8.
On number 8. Yeah, so this one, on number 8, you're going to have to do some distribution. So this negative 5 is first distributed into both of these two terms. So after that distribution, I have a negative 25. Negative times negative is a positive, so this can be a positive 30n. So I'll have to copy down that 3n. And then on the left-hand side, I have negative 91. Combining my like terms, these are like terms because they have the same variable to the same power. And then from there, it's going to be 33n. And I'm still adding that to the negative 25 and setting all this equal to negative 91. From there, I'm going to add 25 to both sides. Add 25, add 25. That will cancel out the 25s. I will be left with 33n on the right-hand side. On the left-hand side, ooh, this is going to be fun. I'm going to go up to...
Isn't it 74, right?
Not quite. So if you're thinking, you're really doing, whenever you're doing opposite signs, you are subtracting. Is it 74? 74 would give you 99. So it has to be 66, I think. Negative 66. But you can check. So 91 minus 25 here on the left-hand side. I have to borrow. This turns into 8. This now turns into 11. 11 minus 5 is 6. 8 minus 2 is 5. Ooh, I was off then. Or 8 minus 2 is 6. I was right. Okay. Yeah, so it is negative 66. And then from there, I'm going to divide both sides by 33. Divide the left-hand side by 33 as well. My 33's cancel out, and my final answer is n is equal to negative 2. And I box it. Ooh. There it is.
I don't know how I got 74 then. I probably just subtracted.
Yeah, I'm guessing it was a subtraction problem. I'm going to move on to number 20.
Or didn't you say we're going to do
Oh,
algebra
wait,
15?
do you do number, actually...
14, 15?
I'll just check.
Oh yeah, so these guys, remember that the instructions, I changed these. Instead of solve, it's supposed to now be graph. Graph each compound inequality. So I have to solve this one, and then I'll do this one in a second. So solving the left inequality, I have to subtract 4 on both sides, subtract 4. And that's now giving me 4p is less than 28. From there, I'm going to divide both sides by 4, divide by 4. That cancels out my 4's, and now p is less than 7. So that's good. I'm going to graph that in a second, but I want to first solve my inequality on the right-hand side as well. So on this one, I'm going to subtract 9, subtract 9. That's going to cancel out those 9's. I'm left with negative 5p is less than, this is going to be 15. And now I'm going to divide by a negative. Ooh, dividing by a negative, that's the one of the two things that will flip the sign. Multiplying or dividing by a negative will flip the sign. So dividing by negative 5. Now it's a greater than sign, and my p is all by itself. It's isolated, and I have a negative 3. So now I ask myself the question, where are negative 3 and 7 on a number line? And I make that number line. I'm going to say that negative 3 is to the left, so here's negative 3, and 7 is on the right. I'm going to say that this line here, which is kind of wavy, represents our x, all the possible solutions. So if I graph any number or graph a point, that is a solution. So I'm going to have an open point at 7 because you can say open matches with these signs, and a closed dot matches with these signs. There's going to be an open point at 7, open point at negative 3, and then it says p is less than 7, so I'm going to go to the left of 7. And p is greater than negative 3, so to the right of negative 3. And this is where you finally use this keyword and. And I'll write out these notes to the side as well. If I have the word and is where you have overlap. So where do the two lines overlap? And they don't overlap here. They don't overlap here. They only overlap in between in this area. So the solution that you'd be looking for when this is a multiple choice question is something that looks like this, where I have a graph from -3 to 7, both open points, and something that is purely in between -3 and 7. That's the answer. And Charles is racing the Wampus. Good luck, because those are hard. If I have the word or, that is where there's any line. That's a bad Y. Any line. If there's at least one line, you're good. So that was number 14.
So this test is going to be multiple choice?
It is purely going to be multiple choice, yes.
Even the word problem at the end?
I think the word problem at the end is also going to be multiple choice. That is going to change once you get into geometry, though. Let's do number 15 as well. People had questions on that, right? Yes, I see people nodding heads. All right, so again, solving, I'm going to subtract 7 on both sides. That'll cancel out the 7. I'm left with a -9x, still less than, because I haven't multiplied it or divided by a negative. I've only subtracted. So these are both going in the same direction. They're both negative, I suppose. So you add them, and I get -72. From there, I'm going to divide both sides by a -9, divide by a -9. A negative divided by a negative is a positive, so this is going to be a +8. And because I've divided by a negative, I'm going to flip the sign. It's now x is greater than +8. I can really copy down the or as well. I can come down here and copy down the and that I forgot. So I'm going to just add 9 to both sides, add 9, and that cancels out the 9. I now have x is less than -4. So technically, I could just copy that down. X is less than -4, so it's all in yellow. I need to now graph these two statements on a number line. When I do that, here's my number line, label it X. I'm going to graph -4, which is to the left of 8. And I would say I've seen 2 students so far that made this mistake of putting 8 on the left-hand side and -4 on the right-hand side. So be careful that the more negative number is on the left-hand side, or the smaller number maybe, if that's how you want to think of it. Again, both of these are going to be open points because there's no equal to sign, so I'm going to have an open point at both of them. I guess I should change my color here. Open point at both of them, and I'm going to say x is greater than 8, so to the right of 8. Or x is less than -4, x is less than -4 to the left. And that's my graph that I'm looking for. Or is wherever there's at least one line. Well, there's at least one line right here, so that is already a solution. There's at least one line right there, that's already a solution. This is the solution. There's no additional step that I need to take. I'm looking for that answer in my multiple choice answers.
So, Mr. Sindel,
Yes.
if it's negative, it'll be closed, or
If there's no equal to sign under the inequality, then it's going to be open. And if there is an equal to sign with the inequality, it's going to be closed. And you guys have a living textbook as well up here in the top right cabinet. You can use that, yeah.
Wait, okay, so if it's multiple choice, what's the answer gonna look like if it was like this?
I'm going to have 4 graphs, and you have to choose the right graph.
Oh.
And that is the right graph that you should be looking for. All right, and I'm pretty sure most of the graphs are going to have the correct numbers. They're all probably going to have -4 and 8. I haven't actually made it yet. And then they're all going to be doing different line things that are happening. So I highly recommend copying down that table that you had in your notes of there's 8 possibilities, 4 for or and 4 for and. If you just copy down each of those 8 possibilities, you'll have one of the answers. The next question that people had was number 20, and I can always jump around too if you guys want it. Kira? 20?
Keep going too fast. I'm at 22.
Oh, okay.
Somebody wants to know.
Let's do number 20, the slope of the line. The slope is always the coefficient of the x variable. So ignore the 4, that's just a constant. This right here, without the x, is the slope. It's the number out front of the x. That's the coefficient. So the slope here is just -2/5. It's always the number out front in front of the x. Next problem that I have up on the board is 20. Do you want to do 22? Is that right? 22. All right. So I highly recommend looking at your notes, the difference between horizontal and vertical lines, because those are going to be on the test. This one is going to be a horizontal line. The way that I know that is y is -4. So on this y-axis, I'm going to come down here to -4 and make a point. I think most people made that point. But now the question is, what do you do? What sort of line? Do I go a line like that, a line like that? And the answer is it's almost always, like 99% of the time, is always going to be going at a right angle through whatever this letter is. So if this letter is y, it needs to be going at a right angle. It needs to be cutting through that y at that point. And let me use technology to make this a slightly neater line. There's my line. Y is equal to -4. Esha?
So if it were, is it ever x is equal to?
Yep, you might see that in the
If
test.
x is equal to -4, it would go through -4, but vertically.
Exactly. So x equals -4. I go on the x-axis. I come over here to -4, make a point, and it needs to go at a right angle, so it needs to come down like that, and that would be x equals -4. Yeah, good question. It's a good question because now you have both possibilities now in your notes, right? And if you can put your teacher cap on, how does a teacher think? What would Mr. Sindel do to switch these to test me? And I probably will switch it to an X. Yes, Emma.
Can we do 21?
Yeah, 21. So I'm going to sketch this line. So this is in point slope, or not point slope form. This is in slope intercept form. Here's the slope. Here's the y-intercept. I'm first going to graph the y-intercept. The y-intercept is 0, 1. 0, 1, or 1 on the y-axis, I suppose, if you want to just think of it simply like that. And then from there, I'm going to use the fact that this is the slope to find my second point from my first point. My top number represents how much up or down if it was negative. And assuming that the top number is always the negative and the bottom number is always positive, this one will always say right. So I'm going to go up to right 3 from my current point. So up to right 3. And I can go up to right 3, and I can do the reverse of that. I can go down to left 3, down to left 3, and I can have a bunch of points to make it a very accurate line. And there is the line 2/3 x plus 1. The next number that I'm going to be doing is number 23. So coming down here to 23, this one is in standard form. And we haven't seen this easy of a problem in a while, but maybe it's so easy that it might be confusing. This one is just saying 1x, oh, that's the wrong marker, there we go. We're saying 1x plus 1y equals -3. So when I have standard form, I want to find the x and the y intercepts. That is, plug in 0 for x, or cancel out that x, and then find the y-intercept. Well, 1y is equal to -3. I've solved it. I don't even need to do any work. The y-intercept is -3. So I come back down here and say, okay, -3 on the y-intercept. If I plug in 0 for y, right here, this y is now 0, which cancels out that term. The x-intercept, therefore, must be -3. So I come over here and I say the x-intercept is -3. I now have 2 points. 2 points makes a line. So I'm going to make a line through those 2 points.
So this one is when you have to use the 0.
This is when you use the 0, yep.
Okay.
When it's in standard form and I need to graph a line, that's when you're going to find the
But
x
that
and y
doesn't-
intercept by plugging in 0.
That doesn't really make sense though, because if it was like that, wouldn't you just think it's 1?
What do you mean? What is 1? Like x is 1?
Yeah.
So I guess I can show you the harder version to show you what it looks like. So if I had like 2x plus 3y is equal to 6, normally if I plugged in 0 for y, this term would cancel out and I'd get 2x is equal to 6, and I divide both sides by 2, and I could say divide by 2, x is equal to 3. This one is even easier. If I cancel out this y term, I now have 1x is equal to -3. That's the same thing as just x is equal to -3, or dividing both sides by 1.
Okay.
Yes. Yes. So number 24 has been pointed out multiple times that it doesn't really work. It comes off the graph. So I'll show you why it doesn't work first, and then I'll show you another way to do it that you have learned. It's just I didn't mean to put this type of problem on the final. I'll make number 24 a nice problem on the actual final. So technically what I'm supposed to do is I'm supposed to say, okay, plug in 0 for y, so that y term goes away, and now I have 2x equals -15. Dividing both sides by 2 gives me x is equal to negative 7.5. But negative 7.5 is out here somewhere, and it's off the graph. I mean, we could extend the graph to make it on there, but there's an easier way. And now I will show you that easier way. The easier way is to do this. Change it into slope-intercept form. Change it into y equals mx plus b form. The way that I do that is I first subtract 2x on both sides. And now I have the equation. I'll come and move up here. I now have the equation 5y, because the 2x's cancel out. I just have the 5y on the left. Copy down the equal sign. And I want to put this negative 2x first. Negative 2x minus 15. All I've done so far is I have, it's a bad 5, I have subtracted 2x on both sides. Well, to get this just y by itself, to be in the proper form, y equals mx plus b form, I need to divide every single number by 5, or technically dividing both sides of the equation by 5. When I do that, I now have it in slope-intercept form. It's negative 2/5 x minus 3. If I can change the form, it's a lot easier to graph. I now graph the y-intercept. The y-intercept is negative 3. Come down here to negative 3. I graph that. And then I use the slope to tell me how much up or down to go for the top number. So I go down 2, and I go right 5. So down 2, right 5, and there is my point. Or I can do the reverse of that. I can go left 5, up 2. And you can see when we make our line through those 3 points that the x-intercept is very much off the graph. So I'm not going to do that hard of a problem on the final. I just want to make sure that you know how to do 2 different problems that are in standard form.
Should we do number 7? Or
Yeah, let's jump back to number 7.
no, 27?
27? 27 is going to come right after 26, yeah. So someone asked a question for 26. So 26, 27, and 28 are next. All right, so number 26, right?
Yep.
All right. I need to find the slope-intercept form of this line. So the slope, you can just kind of make 2 lattice points. I'm just going to randomly choose these 2. The closer your lattice points are together, that means you won't have to simplify your slope or your fraction for your slope. So to go from one point to the other, I go down 1, so minus 1, and then right 1, so plus 1. So slope, by definition, is delta y, the change in y, over delta x, the change in x. So my y, how much up and down I moved, was negative 1. I'm just filling in these numbers into this formula now. Delta y is negative 1, delta x is 1, and negative 1 over 1 is just negative 1. So the slope is negative 1. Well, where's the y-intercept? That's even an easier question. The y-intercept is wherever it crosses the y-axis, and it's a very clear point. It's negative 2. So I can say that my b is negative 2, and my y equals mx plus b, or my m is equal to negative 1. So if I come down here, my original equation is y equals mx plus b. I know my m, I know my b, so I can come down and say my final answer is y is equal to negative 1x minus 2. And some people don't like leaving that negative 1. Some people write the equation y equals negative x minus 2. And that's a little bit more formal, so that's the one I'm going to box. But technically, both of those are mathematically correct.
Can we do 37 after this?
37, if you can write it on the board for me, it'll be a while before I can get to it, but I will definitely try to do it. Next is number 27, unless someone wants to get more time on number 26. So number 27, this is, it's one of the harder problems. So I need it to be in slope-intercept form, so that means it needs to be y equals mx plus b form, and it has to go through this point with this slope. And we've done one lesson on doing this, so it is a little bit, it was a while ago, I guess. If I fill this in, I have y equals, my slope is m, right? So I can say that this m, I can do an arrow, that's 1/2. So I can say y equals 1/2 x plus b. And now the only thing I need to find is this b. Once I find that b, then I'll have the answer. I'll just fill it in. The way that I do that is I fill in my other variables. I have variables x and y, and hey, check it out. I have an x and a y. So I'm going to fill in those variables. This negative 3 is going to go into that x. This 5 is going to go into that y. I'm going to rewrite this equation as 5, in parentheses, because I'm doing substitution now, is equal to 1/2 times, using parentheses again, negative 3 plus b. Now I have an equation with one unknown. Again, that's kind of the whole goal of algebra. When you hit algebra 2 and you hit algebra 1, everything, you're trying to get one variable by itself and then solve for it. Well, I guess whenever you're trying to solve, you're trying to get one variable by itself. Even in college, you're trying to get one variable by itself. And it's a struggle still. I'm going to simplify this right-hand side. This is technically -3 over 1. You can always put anything over 1. And I'm going to multiply straight through. On the top, 1 times -3 is -3. On the bottom, 2 times 1 is 2. So I now have the equation 5 is equal to -3/2 plus b. And Mr. Sindel does not like fractions. You might not like fractions either. Whenever I see something like this, I immediately get rid of the fractions by multiplying everything by whatever this denominator is. And maybe this is a trick that you don't like me using. I can come back and solve it a different way if you would prefer. But I'm going to multiply every single number here by 2 to get rid of the fraction. If I multiply this by 2, oh, I can't do that though, can I? It's going to cause me to do more work because then I'm going to have to divide by 2 right away. I would be a hamster running in a wheel. So scratch that. We're just going to have to add 3/2 and deal with the fractions. So I'm going to say I have to undo this -3/2. So I'm going to add 3/2, add 3/2. And my final answer is b is equal to 5 plus 3/2. But I need to simplify that. So I'm going to multiply this 5 by 2 over 2. So 2 over 2 to get common denominators. So this is now going to be 10 over 2 plus 3 over 2. And that is going to be 13 over 2.
What did you do? You did 2 over...
I just multiplied this 5 by 2 over 2. Technically, it used to be 5 over 1. And in order to get like denominators, I need to multiply by the fraction 2 over 2.
And so that's the answer, y equals 1/2 x plus 13 over 2.
Oh, you're right. So that is the final answer if I plug that 13 over 2 back in. So let me come back over here. I'll still draw that one. I need that. I boxed the y-intercept, which is not the final answer. I can come back and say, yes, this 13 over 2 goes into that b. And then I can actually write down my final answer, which is y is equal to 1/2 x plus, instead of b, 13 over 2. And that's the answer that I boxed. Thank you, Kara.
So then how did you get 3/2 after 2 over 2 and then
So this 3/2 right here?
yeah.
So that 3/2 came from adding 3/2 to both sides to get b by itself. So I had -3/2. If I add 3/2 to both sides, that cancels out, and b, this thing that I was trying to solve for, is equal to this 13/2. That's kind of this giant chain of logic that eventually says b is equal to that 13/2. Yeah, good question, good question. Keep them coming.
So 8 is the same too? Like,
Say again?
28 is like the same?
What is 28? Oh yeah, same thing. But harder. That's actually harder because it doesn't give you slope. This one said, hey, here's your slope, 1/2. This one's like, haha, we're not going to give you slope. You have to find out slope first and then do all that same work that you just did in number 27. So,
Could we do 28?
say again?
Could we do 28?
Yeah, 28 is the next one we're going to do. So first, I need to find slope. Generally, the way that we want to think of this, okay, we see the word slope-intercept. We're like, oh yeah, that's y equals mx plus b, where I need to find b and find m. Well, b is the harder thing to find unless, oh, wait, it's actually the easiest thing to find. Check out that number right there, 0, 2. We got lucky. Sometimes that might not happen on the final, but that is the y-intercept. If I think about the number 0, 2 and graph it, the number 0, 2, I go 0 in the x direction, so don't go left or right and just come straight up 2. Well, that's a y-intercept. It's on the y-axis. That means my b right here is 2. We've found b.
Why isn't your b 5?
So b is not 5 because in order for it to be a y-intercept, the x value has to be 0, and this x value is -3.
Oh.
Yeah, so this is actually going to be our b, our y-intercept, and we got lucky there. I'll show you what would happen if we didn't have that. So let's pretend I didn't know that was my y-intercept. Let's solve this all from scratch. So first I need to find my slope, my m. So to do that, I have to define the slope, and I'm going to use Kira's formula. So she defines slope as y2 minus y1 all over x2 minus x1. And some of you say y1 minus y2 over x1 minus x2. That's also fine. It doesn't matter the order as long as it's 2 minus 1, 2 minus 1. You can't do 1 minus 2 and then 2 minus 1. That would flip it. You'll get it a negative times whatever the slope should be. When I substitute everything in here, my y2 is 2. My y1 is 5, so 2 minus 5. My x2 is 0 minus. My x1 is negative 3, so I'm going to do minus a negative 3, a double negative. When I do all that, I'm going to get a negative 3 in the numerator, a positive 3 in the denominator, which simplifies to a negative 1. So my slope is negative 1. And technically, because we have our shortcut 2, we can write out our answer now, but I'm going to show you the long way. So finally, we can say it. Y is equal to negative x plus 2. That is our final answer. We can get that right now. But let me show you what would happen if we didn't have that. If we didn't have that, we'd say, okay, now I have the equation. I can fill in this negative 1 in for this m. And I can say this is now y equals negative x plus b. And I need to solve for that b somehow, just like we did up here. To do that, we needed to plug in our x and y value. And you could use either one of these. Let's just choose the easier one because we want to be finished with this problem. 0 is x, so I'm going to say 2 in parentheses is equal to negative in parentheses 0 plus b. Well, negative 0 is just gone, and therefore b is equal to 2. And now I can say, oh, now this 2 can be plugged in to this b, and we have our final answer. Again, y equals negative x. I'm just copying down right here, negative x plus b, but instead of plus b, it's plus this b that I found down here, which is 2. All right, so that was number 28. The next one to do is number 29 and then 30. All right, no one's raising their hand, so I'm moving on. We are solving these by graphing. So my first two are in slope-intercept form, which means I'm first going to graph my y-intercept and then use the slope to find my second point. So first my y-intercept is 4. On my y-axis, I graph the point 0, 4. And then I'm using my slope. I always assume that the top is the negative one if there is a negative sign. So this means down since it's negative. So it goes down 3, and the bottom number should always be right if you're using this method. So down 3, right 2. Down 3, right 2. Down 3, right 2. So those are going to be my blue equations. Let's go ahead and make that a line in blue. All right, and then I'm going to make this my yellow or orange equation. Oop. I'm going to make this, come on now, grab this line, change it back to blue. All right. My next one is going to be orange. I'm going to graph my y-intercept of negative 2. So 0, negative 2. And then I'm going to go right, oops. I guess I'll start saying up 3 and then right 2. So up 3, 1, 2, 3, right 2. And it's the same point right here. And then up 3, right 2. And I can go the reverse as well. I can go left 2, down 3. And I have a bunch of points that I can graph. And we can clearly see, oops, let me get this line correct, that our answer is that intersection of 2, 1. So the answer here, solved by graphing, is 2, 1. We are now on to number 30. So number 30, this one is in standard form. Standard form is where we find the x and the y-intercepts by plugging in zeros. I'm first going to find my y-intercept for my top equation. That means I'm subbing in 0 for x, so that's gone. Now I have the equation negative 2y is equal to negative 2. If I divide both sides by negative 2, I get the equation y is equal to 1. Again, divide both sides by negative 2. A negative 2 divided by this negative 2 is a 1. So my y-intercept is 1. There it is. Let's find the x-intercept by, instead of crossing off the x, kind of substituting 0 in for y, which means this entire term is gone. I now have x is equal to negative 2. Well, if x is equal to negative 2, the x-intercept is negative 2. And then I can graph a line that goes through there. And you can kind of see, oh, well, the slope, therefore, is right 2, up 1. So that means I can just continue the pattern, right 2, up 1, right 2, up 1, left 2, down 1. And I have a bunch of points that makes a very, very accurate graph. There we are. All right, switching to orange. Let's find our y-intercept by subbing in 0 for the x. Now I have negative 2y is equal to negative 6, dividing both sides by negative 2. And that gives me y is equal to positive 3. Y is equal to positive 3. I'm graphing that y-intercept. The next thing that I'm going to do is I'm going to come back here and delete these guys, get them out of the way. Sure, we'll just get rid of that. and I'm going to substitute 0 in for y, which means my x is -6. So I come over here and, oh, I can't do that, which is unfortunate. What happened to my 3? There it is. Again, it's off the graph. Okay. I need to write a note to myself that this one didn't come out well either, so I'll check this one out. Number 30.
Oh, I didn't
Mr. Sigal, can we also do 32?
Yeah, 32 as well.
Oh, yeah.
Which means, unfortunately, this one you have to turn it into slope-intercept form. We can do that kind of quickly. So if I just subtract x on both sides, I now have the equation -2y. I should switch to orange here. -2y is equal to -x minus 6. All I did right here is I subtracted x from both sides, and that x went away. I now have that -2y by itself, and dividing every single term by 2, or -2, and that's going to be showing my work, showing my work, showing my work. This is now going to be y is equal to 1/2 x plus 3. So 1/2 x plus 3. Oh, what's happening here?
Wait, why is it 1/2 x?
It's 1/2 x because I'm right now, in order to get it into y equals mx plus b form, I'm dividing every single term by -2. So a negative divided by negative is a positive, and this is kind of -1x divided by -2, and that's why I have the 1/2. You can technically leave this x over 2 if you want, but it's a little bit easier to see the slope if it's out front as a coefficient. So that means I'm going to go right 2 up 1, right 2 up 1, left 2 down 1, left 2 down 1, and it looks like we have parallel lines.
We got the exact same thing, except for you did way more math than I did.
Oh, okay. If we have parallel lines, the answer is no solutions, because they never intersect. Again, the solution is represented by wherever the lines cross. It might be an infinite number of points if it's the same line. This is the case where I have the same slope but this different y-intercept, which means the answer is no solutions.
Never mind, you just rewrote the whole. Okay.
I had to rewrite that bottom equation now into slope-intercept form. Yeah, that one was tricky because it wasn't easy to graph. I will double check to make sure that those are easy to graph. From 30, it looks like we're going to 32 and then to 37.
We do 31.
Yeah, we can do 31. So 31, substitution. So substitution states that we need to solve for one variable, but we already have one variable solved for, like y is equal to all of this, which means if all of this -3x minus 5 is y, then this y must also be -3x minus 5. So this -3x minus 5 is kind of being plugged into this y. So I'm going to rewrite this bottom equation, I'll write up here, -6x minus 2, but in the place of y, I'm now substituting in -3x minus 5. And then copying down the equal sign and 10. And doing that substitution now will eliminate our y variable, and we only have x's, which was the goal, right? We wanted to get one variable. From here, we have to distribute this -2, not just the 2, distribute this -2 into both of these two terms. I now have that -6x, which I have not touched yet, and plus 6x plus 10 is equal to 10. And this is going to be an interesting problem. I'm going to combine these 6x's, -6x and a positive 6x combines to just cancel out, and I am left with 10 is equal to 10. What?
I know the answer.
What is the answer? What?
Infinite solutions.
Yeah, the answer here is infinite number of solutions.
So why wouldn't you just subtract 10 on both sides?
You could, yeah. If you want to subtract 10 on both sides, you could get 0 is equal to 0. But as soon as you hit a number is equal to the same number, that automatically tells you you have infinite number of solutions.
Wait, and so then here you don't. So if you have infinite number of solutions, you don't have to solve for y.
Nope.
Okay, so okay.
I'm trying to think, does that make sense in terms of a graph? Can you have an infinite number of x answers but only one y answer? Actually, you could. Can anyone think of a graph where you have an infinite number of x answers but a finite number of y answers?
That only it's like when you only graph one point.
It is, yeah. It's when you graph this. Graph 1 point and like that. This line has one value of
Y.
all of these values of y. Oh, I'm graphing it the wrong way.
One value.
I should go like this. So how many values of y work? There's, oh no, that still has an infinite number of answers working. Darn, I thought it was like that, but no, it's not. I don't, yeah, it's infinite number of solutions. There's no possible way of making a graph where I have only one x and no y's. Or sorry, one x and infinite y's, or vice versa. All right, that was 31. 32 is also asked for using substitution. Okay, so now we are at a harder part because we have not isolated one of these variables. So I first need to isolate one of these variables. I can either choose one of these four. I can isolate for that x, that y, that x, or that y. I'm going to choose the easiest one, that y right there. Because it doesn't have any coefficients, I won't have to divide anything after I add the 5x. So on this bottom equation, I'm going to add 5x to both sides. When I do that, the 5x is now eliminated, and my new equation is y is equal to negative 20 plus 5x. And because I didn't have any coefficient, I, again, don't have to divide by anything, and I can immediately say, hey, oh yeah, Kira.
I have y equals 5x minus 20.
That will, yeah, that's perfect. Either way is fine. Yeah, that's the commutative property of addition. And then, since this y is negative 20 plus 5x, this y must also be negative 20 plus 5x, so I can say, rewriting this top equation now, I have negative 5x minus 6, but not y anymore. This y has been substituted for negative 20 plus 5x, and just copying down the equals 15 equals 15. Now I'm going to distribute this negative 6. If there's a negative, make sure it's distributed. So negative 6 is going to distribute into both of these two terms. That's going to be leaving me with a negative 5x, which I haven't touched yet. Negative 6 times a negative 20 is a positive 120. Negative 6 times positive 5 is a negative 30, and then don't forget the x. And that's equal to 15. I'm going to combine my like terms. My like terms are negative 30x and negative 5x. So that's going to be a negative 35x. Plus 120 is equal to 15. I'm now going to subtract 120 from both sides, minus 120, minus 120. And that will leave me with negative 35x is equal to negative 105. I'm almost done. My final step is to now divide both sides by negative 35, divide by negative 35, and that's 3. A negative divided by negative is a positive, so x is equal to 3. Kind of a general tip for these larger division problems is Mr. Sindel likes it when the numbers come out to integers. That doesn't always happen in math, but it sometimes does. 15 minus 120. Because these are opposite signs, I'm going to subtract. So 120 minus 15 is 105, and then I take the sign of larger, and it's negative 105. Yeah, good question. I'm not done. That's only half the answer. Oop, go away. I now need to plug in that x equals 3 into one of these equations. I kind of like subbing it into this blue equation right here. You can sub it into any equation that you ever see up here. So I'm going to rewrite this blue equation. Y is equal to negative 20 plus 5, not x anymore, but the 3 that we had down from below. So this 3 came up right here. And then from there, I'm going to go ahead and multiply these out. So it's going to be y is equal to negative 20 plus 15, and therefore y is equal to negative 5. And now I have my two answers. I can box both of them. My answer is 3 comma negative 5, or just x is 3, y is negative 5. And we got out of here at 53, so that means I have 2.5 minutes. I'm jumping to number 37. And I think that's probably going to be all the time I have left for.
Yeah, could you do number 35?
I can do 35, but I'm going to only spend 20 seconds on it. I'm going to run it through it really fast. I need to multiply the top and bottom by something. I'm going to multiply by 2 on the bottom, 2 on the bottom. I'm going to rewrite this as negative 2x minus 16y is equal to 60. Now my 2x and 2x from the top and bottom equation will cancel out. I'm left with just negative 12y is equal to 60. From there, I'm going to divide by negative 12, and I get y is equal to negative 5. From there, I'm going to plug in negative 5 into this equation yet again, and I'm going to get negative x minus 8 times negative 5 is equal to 30. This is going to be negative x plus 40 is equal to 30. Or subtract 40 on both sides, I get negative x is equal to negative 10, and x is therefore equal to 10. The answer is 10 comma negative 5. Sorry I can't spend too much time on that. I really need to get to 37. It's our hardest problem, one of the hardest problems on the test. I have exactly 1 minute and 15 seconds to do this. Selling tickets for the talent show. Zoom out, please, computer. Thank you. So 12 senior citizens. So I'm going to do S for senior citizens, C for child. So 12S plus 1C for $179. And the school took $47 the next day by selling 1S, 1 senior citizen, and 3 child, so plus 3 child. And then I need to solve these in any way that I choose. I feel that probably substitution might be easier, or maybe you like elimination. Maybe eliminate. Those numbers are big. It's going to be big either way. I'm going to do substitution. I'm going to say subtract 3C on both sides. I'm now going to get 1s is equal to 47 minus 3c. So I have one equation, my other equation. I'm now going to say that this s right here is 47 minus 3c. So I have my new equation that states 12, now 47 minus 3c plus c is equal to 179. From there, 12 times 47. We don't have calculators on the test, but I am out of time, so sorry. 12 times 47, 564. 564 minus 36c plus c equals 179. You guys are dismissed, but I'm going to keep recording the video so it's up online. I'm now going to have negative 35c by combining these like terms. I need to also subtract negative 564, so minus 564, and on the right hand side, again, I would have time to do this normally. 179 minus 564 is negative 385, negative 385, and divide both sides by negative 35. 385 divided by 35, and that is 11. So c is equal to 11, and I have to plug it back into one of these. If this is 11, that's going to be 1s plus 33. C is equal to 47. 1s plus 33 is equal to 47, and subtracting 33 on both sides, I get 14. So s is equal to 14, and there is the final answer.